Hello and welcome to Captain Bob. Today we'll be making the attitude indicator. For this build, you'll need these 3D printed parts, 2 motors and their drivers, honk honk, an Arduino Mega, some wire, these micro switches, all of these nuts and bolts, which are right here. I've never gotten my nuts and bolts list right on the first time, so might as well put it in editing. And these decals. You'll only have to print them once, and I recommend doing it on a shipping label. Set your quality to high, but I had to do it more than once. I am so sick of this decal. And funny story, this version isn't even right because it prints over the seam. You'll get the good version though. You'll also need a smudgy desk that makes you question how oily you are. Let's start out with the front piece. You'll need this bezel piece, this glass piece. This, I think, is called Cover Thyself. You'll also need this airplane piece, and this can be printed in orange. You'll need this gear piece, and then this knob piece, as well as this backing piece. So let's just focus for a second. So let's start out with the bezel. Let's take off this covering for the glass. Take a second just to marvel at how clear the glass is. Ignore this hole. Align the hole right here. And then have this piece right here. Put in the gear. Put in the airplane. Where'd that fly off to? Here it is. This side is correct, but if for some reason you want to switch the orientation, you just flip over what side the gear is on. So we're good like that. And then we put on this back piece, and you'll probably want to paint this black and then use some paint marker to get the orange ticks. Align it, put it through, and push it in. Push it through and push it in mean the same thing. Now we put this square thing on the other square thing. There we go. Now if anyone complains about not having a great view, it's adjustable so you can make it perfect. That's the rules. Let's put this to the side. Put it right here. Yeah, there's not really anywhere else to put it. Originally in this video I had this core right here. The problem with this is that there's too much friction between this plate and this arm, so it'll often get stuck with the motor. Another issue is that these micro switches, I actually took them out here, interfere with this cage here. You couldn't go past a certain point. In the second version, I put 2 spots in for Hall effect switches. The beveled edge goes up, and then you can add some glue so it stays in place. The wiring for these is exactly the same as the wiring in the heading video, and you can see that right here. Now let's let this dry and go on to this part right here. This time I'm going to choose this decal with numbers and align it with the midpoint right here. There we go. This looks pretty good, pretty centered. Now let's take this part. Okay, we actually have these little nubs right here that help you align the line. Now make sure the blue side is up. It's just a good rule of thumb with your airplane. And make sure the crease aligns at the other side too. Now we can cut around the decal. Make sure to cut consistently so that you don't have spots that are bolder than the others. And I'd say that's pretty good. Luckily, the edges will be covered up. So, by this piece actually. Oh, barf. Be careful where you put your decals because they might ruin your other decals. So we printed the new decal, and now let's apply it. All right, that looks all even. There will be alignment nubs, I call them, little bumps, just to tell you where the edge should be. And those will help you make sure it's perfectly aligned. I really like how the X-Acto knife performed versus the box cutter. For this, we're going to wire it up first to some other wires, but it just snugs in and fits in right here. There's a little pocket, and then it fits in there If you need to, you can glue it, but it fits in there, and then you can guide it around the screw. Up next, we're going to add in the motor. Push the connector through this rectangle, and then fit it through the large hole. Or the, I guess, smaller hole. Yeah, the large hole. And then fit it through this hole. We can put in these 8mm countersunk screws. This might even be 6mm. Make sure it's centered. You might have to move it around a little. In this case, I had to pop it in. Now I'm gonna grab these 10mm screws and thread them through the back here. And before we put it in, let's put in the magnets. So with these Hall effect switches, this south side of the magnet should be facing the front of the Hall effect sensor switch. And that's what triggers it. Beep, trigger, beep. To find the south side, we're going to use the north side. And we know that the south side is attracted to the north side, the red side. And so we know that this right side of this small magnet is south. Now we can put it in through its little cubby hole, like so. And we know it's south because opposites attract, so the same repels, and this is repelling. So just make sure the south side is pointing inward. Now we can put this over the roll part, and we can make sure that it just operates smoothly and it hits both of these limits. Then let's add in the roll screw. Ooh, such an original name. You want to make sure this is loose so that the screw isn't actually engaging with it, it's just aligning it. And here we go. This looks good. Now you'll notice that this moves really smoothly. There's no engagement at all. And if there is any engagement, then you're wrong. There shouldn't be. You should need very little force to move this up and down. That's the idea. If you have to scrape and really add a lot of force, then this isn't gonna work very well for you. Let's put on the roll cover. I really prefer to get it started right here, put these in, and then add the cover. And of course, make sure all the decals align. You don't want any upside down because that would stink. That would be terrible. These are M3 14mm screws right here. And once again, we shouldn't have any friction at all. We should easily be able to move this bar right here. One of the last steps is to do the same thing we just did. We need to use the north to find the south, and then place it in here. We can see where our attitude is coming from. Let's add our stepper motor to this part, wire up our Hall effect switches, and go from there. After you have these two parts all wired up, you can get the wire loom and press it through this smiley face slot in the back. Then once you have the wiring loom in, we have these nuts right here. They're 6/32. These are actually imperial, but you can use metric as well. And then just slide them through their slots. They should stay in place decently well, but if they fall out, you can put some glue in. Now you can mount this cage piece and press down using the back piece right here. You don't want to press on here because that might make the screws come out. And now just make sure that everything moves smoothly. And this won't actually spin continuously, otherwise the wires would tangle around, they get all twisted. So we have a limitation of minus, I think I said 135 and positive 135. Now we can finally put this piece on, and there are screws here that you can screw the instrument together. And then once we screw in these screws right here, this will connect the instrument. So you don't actually need these screws. These are somewhat optional. All right, let's start off in a blank Mobi flight configuration. I'm not going to cover the wiring in this video because the wiring is actually identical to the heading indicator wiring. 2 zeros, 2 motors. In fact, I'm instead going to put up the wiring diagram now. Just make sure that all of your wiring pins connect up to all of your Mobi flight pins. We're going to do this configuration in X-Plane. Why? Microsoft Flight Simulator has issues. It just crashes to desktop whenever it wants to, which is fine. Yeah, to each their own. If you're instead looking for Microsoft Flight Sim 2020, the steps are the same, and I've attached a FS2020 file in the description below. But regardless, let's go and make 2 stepper motors. I made mine on the first 4 pins, 2, 3, 4, 5. You can make another stepper, 6, 7, 8, 9, and then if you are using zeros, you can use the 0 pin 10, the 0 pin 11 for your zeroing. Of course, you can configure these to whatever you want, as long as they line up with your wiring. This is IN1, IN2, IN3, IN4. But please don't do that. Let's rename this roll and pitch. This setup is not conducive to typing well. I'm all the way over here. And yes, we do want to upload, and we're all set now. Pew, pew. Now let's go to output, and let's make our roll. So this is going to be our attitude indicator roll. Under edit, let's go to X-Plane data ref, search for, let's go under, it would be either indicators or gauges, I think it would be. We have roll right here, roll electric degrees, pilot, I think it would be roll vacuum degrees pilot. And we can test our theory in Flight Sim. Excuse the mess, I'm still moving in. I actually have been moving in for a month now. Fun, fun. So we have indicators, roll vacuum degrees pilot. Let's click OK. And I always just like to make sure that this actually is the thing we want in the flight simulator. So let's test it out. Should be between 60 and 90. And yep, it's between 60 and 90. So it works. Actually, first let's stop it. And under compare, we want to limit this because we want to go, we want the maximum to be 135 and the minimum to be negative 135. So that'll give us a 270 degree window. If you're more than 270 degrees, I think you're starting to have a problem. So shift tab, 135, 135. That'll basically limit the gauge to that window, 270 degrees, negative 135. So basically, if any values are higher than this 135, lower than this 135 value, then it'll just get stuck at this 135. And if they're higher than this 135, it'll just get stuck at this 135. That's what this does. Now, under display, let's use our output device with our Mobi Flight Mega, with our stepper, with our roll stepper. This is the one we want to configure. And our display scale will be 360 degrees. So it'll go 0 to 360. And then for a full revolution, this is just the default value. We're not going to enable compass mode. In an actual attitude, you would enable compass mode. We don't want compass mode enabled. Compass mode basically goes 358, 359, 0, 1, 2, and so on. It lets the motor go continuously. We actually theoretically would want this, but practically we don't, because the cable would get tied up, tangled, like the movie. The cable would get tangled, so we don't want this. We don't want to twist past our bounds. So we're just going to keep compass mode off. Now for manual calibration, this is how you move the stepper to set the 0 point. Set 0. And this test value right here, this is how many degrees we want to test it. So if I go 90, click test, we can go sideways, and then negative 90 is the other way. Sweet, and it works. I'm pretty sure the designers of this house were like, oh, it would be cool if we had a greenhouse in front of it. That would be cool to grow plants. And then they were designing it, and then they're like, oh shoot, I don't eat vegetables. So they turned it into like an office, and now it's just really, really hot. Anyways, for pitch, we're gonna do the exact same thing we did with roll. We're just even gonna duplicate it to save so much energy. We're gonna go to pitch, and I think like four takes ago I called it pitch perfect. That take was 4 takes ago, so it did not go perfect, but I think it's kind of fun to name things funly. Alright, let's click edit and go to sim variable. Roll vacuum degrees pilot. Now if we want this for pitch, what'll it be? Okay, this isn't Dora, it's pitch vacuum degrees pilot right here. Under compare, instead of negative 135 to positive 135, the pitch only goes up 35 and negative 35. So it'll be negative 35, negative 35, 35, 35. And make sure the check mark is on, otherwise nothing will happen. Under display, let's go output, and instead of roll, it'll be pitch. Now, 365, default values here. You can 0 it now, or later, I don't know what you want to do. Oh, and an important thing to know is you 0 it to the bar right here. You don't necessarily 0 it to the airplane. Because you can adjust the airplane. Okay, for a test value, negative 90 is way too much. Let's try negative 35. Click test. Wow, it goes up. It goes up. We'll see later. Now, positive 35. Oh, I clicked OK. Positive 35. Wow, it goes down. Okay. Now let's click save, click run, and we're going to have an airplane experience right here. Yeah, there we go. Now, everything should line up. If it's not, we'll have a talking to it. So far, everything is lining up, which it actually shouldn't be. On your end, it really shouldn't be lining up. What I did in between takes, which I forgot to undo, is under this compare tab, there's this negative 135, and usually right here we have negative 135, but in this case it's positive 135. So we basically flip-flopped. So negative 135 gives out a value of positive 135. Think of it, if I go to the left, I should actually go all the way to the right. It's swapping the values. And then when it's all the way to the right, it's actually going to go all the way to the left. If we get rid of this interpolation setting, by default, you'll see that it's backwards. See? Wrong way. You're dumb. But once we apply this swap, it's the right way. This is like the Russian attitude indicator versus the US attitude indicator, how the pilot was like, oh no, we're turning the wrong way, oh no. Like that. We're actually going to adjust our values even further. We're going to go negative 90 to 90 and 90 to, no, just 90. 90 gives a value of negative 90. And we're going to re-zero it too. Why is this? The attitude indicator on the sim is zeroing out at this 90 degrees here, so I'm just going to match the simulator here. Okay. All right. Whoa. Head rush. This is like when I sit up too quickly and you're like, whoa. You know? All right. It looks like they're matching. Unfortunately, we did a little too crazy of things with the simulator, but it should fix itself in a few seconds. Maybe if I just rock the wings or something. Is there a button that cages it? Oh, I have a button. Oh, I wonder if there's a data ref for that. Okay, so here we are. If you're worried about AI taking over aviation, it's already taking over Flight Simulator. We now have an operational attitude indicator, and this is fantastic because we no longer have to put our arm out the window to see if we're going up and down. You visit their booth at Flight Sim Expo. They have some really cool stuff. And speaking of Flight Sim Expo, go visit the details in the description below because Flight Sim Expo is happening. I'll be speaking. I'll also be doing sessions with Sebastian from Mobi Flight, and we'll be building all sorts of flight sim stuff. Thank you so much to the Patreon supporters for making this video possible. There were a lot of failures in this video. There are so many intricate parts, and if you get the zeroing things too big, it won't rotate. This is actually the second version. I actually refilmed an entire section of this video because I redid the zeroing. That's probably pretty obvious. The intro is different. I completely redid the entire interior part because I switched out the zeroing mechanisms because the other ones just would not rotate and they'd get stuck and snag. There's so many things and parts and places that can break. So thank you to the Patreon supporters for making this video possible. Thank you for watching. If you'd like to become a patron, there's a link in the description below. Thanks for watching. Have a fantabulous rest of your day, and stay spicy. Bye.